Hello everyone, this is Abhinav and today we'll be discussing the very last problem from the CP-31 sheet by TLE Eliminators under the 1500 rated problems. Okay, let's begin. We'll move on to our CP-31 sheet. The 1500 rating mark is checked and let's click on the last problem, which is little girl and maximum sum. Okay, so let's read the problem statement. The little girl loves the problems on array queries very much. One day she came across a rather well-known problem. You have got an array of n elements. The elements of the array are indexed starting from 1. Also, there are Q queries. Each one is defined by a pair of integers li to ri. You need to find for each query the sum of elements of the array with indexes from li to ri inclusive. Okay, so basically for each query, you just need to find the sum of the array from in for the values in the range from li to ri. The little girl found the problem rather boring. She decided to reorder the array elements before replying to the queries in a way that makes the sum of query replies maximum possible. Your task is to find the value of this maximum sum. Okay, so what you need to do is you need to reorder the array elements in such a way so that the final whatever answer you would get for every query, the sum of those answers is the maximum possible. So you need to reorder the elements of the array so that you maximize the sum of answers for your query, where the answer for every query is the sum of the values from the range of li to r. Okay, sum of the subarray from li to r. Okay, so this is the problem statement. Let's understand it from the sample test case. Okay, so you are given n and q queries. Okay, so this is the array given to you initially 532 of size n, and then these are the q queries. The first query states that you need to sum from the range of 1 to 2, then sum the range from 2 to 3, then sum the range from 1 to 3. Okay, so let's say you keep this original array as it is, then what would be the answers for your queries? Sum from 1 to 2 is 5 plus 3. Sum from 2 to 3 is 3 plus 2, which is 5. Sum from 1 to 3 is 5 plus 3 plus 2, which is 10. Okay, so overall the sum of queries would be 8 plus 5 plus 10, which is 23. Okay, now you need to maximize this value by rearranging this array. Okay, you need to rearrange this array in such a way so that this particular value is maximized. So for this array, these were your answer. Let's say you rearrange it to 3 5 2. Okay, for this array, what would be your answer? For the query from 1 to 2, so the sum from 1 to 2 would be 3 plus 5 8, then 2 to 3, so it would be 5 plus 2 7, then 1 to 3 would be 3 plus 5 plus 2, which would be 10. Okay, now the sum becomes 25. As you can see, by rearranging it like this, your sum has increased. Okay, so among all the rearrangements that are possible, you need to find for whichever rearrangement you get the maximum sum. Your final answer is this maximum sum. Okay, so for this particular case, I think 25 was the maximum that you can get. Your answer was 25. Okay, so by rearranging the array like this, you get a sum of 25. The sum of the queries is 25. So this is your final answer. Okay, so I hope you would have understood what you need to do. Now, how do you do it optimally? Okay, so let's look at the constraints of the problem first to understand how optimal we have to do. So n is up till 2 into 10 to the power 5, and q is also up till 2 into 10 to the power 5. Okay, so these are the constraints given to us. So basically both n and q are up till 2 into 10 power 5. That means we can do something like order of n, order of q, all those types of things would be fine. Even adding something like a log n extra to any of them would all be fine. But if you do something like n into q, that would have like 4 into 10 to the power 10 operations. This would not be fine. Okay, this would give us a TLE. So you can basically, these you can say is your expected time complexity, somewhere in order of n, order of q, or the n plus q, n log n, q log n, something like that. If you are able to solve the problem in some linear complexities of n and q, then that is fine. But you cannot go in n into q, or even something like n square, q square. All these complexities would not be fine. Okay, so once you know about the constraints of the problem, let's try to find some optimal way to solve this problem. Okay, so basically what you need to do is, in every query what you get. Okay, so had this extra condition not given to you that you need to reorder the elements and find the answer to the query, then this original problem is a pretty standard problem, that you are given an array, and in every query you just need to find the sum from Li to Ri, sum for the subarray from Li to Ri. So for any subarray, the sum of any subarray can be like calculated if you have pre-computed the prefix sum for this array. Okay, this is a rather standard problem of prefix sum, that if you can compute the prefix sum for this particular array, then you can answer every query in order of one by just, if you want to find the sum from Li to Ri, you can say the prefix sum from till Ri minus the prefix sum for Li minus 1. Okay, this would be my answer. Okay, if you have pre-computed your prefix sum. Okay, this is a very standard problem. But now the difference here is that you can reorder the elements so that these, the answer to the queries that you are getting, if you sum up the answers for all the queries, then that sum is maximized. So now let's suppose, okay, so for every query you are adding this to your answer, whatever is your initial prefix sum array, you are adding this to your answer. Okay, now if you have like multiple queries and you can reorder the array elements, so basically you have to decide what array you need to pick so that these sum is maximized. So if let's say in the first query you have this range, then in the second query you have something like this range, then this range. Okay, so basically what is your final sum? If you have something like this range, okay, let's say here you have 1 2 3 4 5 6 7 8, let's say n is equal to 8. There are 8 elements in the array, and in the first query you have a range from, for the first 3 elements, then next query you have a range for next 2 elements, then next query you have a range for, let's say, all these elements. Okay, let's say these are your ranges. Then in your final sum, the sum, the sum of the queries that you get, what is that? This particular value, whatever value is present here, okay, your final sum would be, if it is, let's say, a1, a2, a3, a4, a5, a6, a7, a8, then your final sum is basically, the answer for first query is, the answer for your first query is a1 plus a2 plus a3. This is an answer for first query. Answer for the next query is a4 plus a5, a4 plus a5. Answer for the third query is the sum from a2 to till a7. So a2, a3, a4, a5, a6, a7. So basically the sum of the queries is this thing. So this is the thing that you need to maximize. So if you want to maximize this thing, then if you write it down, what is that? A1 is coming one time, A2 is coming once in this query, once in this query. So A2 is coming two times, you can see. 2 times A2. A3 is also coming once in this query, once in this query. So 2 times A3 is also coming. Then A4 is coming once in this, once in this. So A4 is also coming 2 times. A5 is also again coming 2 times. A6 is coming 1 time only in this query, and A7 is also coming 1 time. So this is the value that you need to maximize, and you can, whatever initial array you got, you can have any permutation of that array. Basically, you can shuffle the values anywhere. So among the values that you have in the initial array, whichever value whichever value has more weightage, basically this A2 is getting added 2 times in your final answer, A3 is added 2 times, these values are added 2 times, but A1, A6, A7 are added only 1 time. And if you look at 8, it is getting added 0 times. A8 is not added anytime. So what you can do in order to maximize this value, you would try that the greatest value, the greater values should come at A2, A3, A4, A5, so that they are multiplied by a greater value and you get more benefit from that. And you can place the smaller values to this, because whatever you are placing at A8, that is not getting added to your answer. So in order to maximize your answer, what you can do is you can sort your initial array and sort these according to the its coefficients. So if you sort these values according to their coefficients, then we can say that whichever index has the highest coefficient should get the highest value from the array. So if you can find the sorted order for the coefficients, and you can obviously sort the initial array, then you can just write your final answer as if the greatest coefficient is 2 multiplied by the greatest value, then 2 multiplied by the second greatest value, 2 multiplied by the third greatest value, and so on, 0 multiplied by the smallest value. Okay, so we just need to compute these coefficients for every value. So if you can compute these coefficients, then writing the final answer is just sorting and multiplying the corresponding values. That would be done in n log n easily. But how can we find these coefficients? So finding these coefficients is also, you can see, pretty standard, that for every query, if you have a query from the range from Li to Ri, that means you add a +1 to the coefficients of A1, A2 and A3. If you have a query from A2 to A7, add a +1 to the coefficients of A2 up till A7. Basically, you have to add a +1 to a range from Li to Ri. How do you do that? Optimally, you can do that using the technique of difference array. I hope you know about the difference array technique. Just the reverse of the prefix sum technique is the difference array technique, that if you want to add plus x to a range, what you do is you initialize a difference array, and if you want to add a +1 from A2 to A7, then you would add a +1 at A2 and a -1 at one index after A7. If you want to add a +1 from A1 to A3, you add a +1 here and a -1 at A4. Same for A4 to A5, you add a +1 here and -1 here. Now, whatever array you get, if you take the prefix sum of this array finally, then what would happen? This +1, like for this array, if you have added a +1 here, -1 here, when you take the prefix sum, this +1 would just go to all these values, and here this +1 -1 would neutralize to 0. For the rest of the values it would add 0. So basically doing this +1 and -1 finally effectively is doing a +1 to this range. So I hope if you know about the difference array technique, this is how we do it. So using the difference array technique, for every query in order of 1, you can do the +1 -1 thing, and at last in order of n, you can take the prefix sum of the difference array to get the coefficients. Once you have got the coefficients for every index, then you just need to sort those coefficients. Okay, so whatever coefficients you get, sort the coefficients and also sort the initial array that you get. And once you have sorted both of them, yeah, sort them in reverse order from greater to smaller, and once you have sorted them, your final answer is just the product of this coefficient array multiplied by the sorted array AI, the sum of that. Okay, so I hope you would have got the logic what we are doing. Let's do a quick dry run on any one of the test case. Let's say for this test case, if we do a quick dry run of what we are doing, so you have this n and q. So you have this initial array A and these q queries. So you would maintain your difference array. Okay, first you would compute the coefficients, how many times a particular index is getting added. So for that, we maintain a difference array. So let's say I'm taking zero based indexing only. So from 0 to 5, 0 to 4 would be the indexes, and 5 an extra index is stored because you're doing -1 at +1 index. So we always store the index, one extra index in our difference array. Okay, so now we initialize the difference array with zeros. So if you are, if you we have a query from 1 to 5, just convert that to zero based indexing so that it's from 0 to 4. Okay, so from 0 to 4 you need to add +1, so do a +1 here, and at 4 plus 1 5 you would do a minus. Okay, this is 2 to 3, which is actually 1 to 2 in zero based indexing. So at 1 you would add a +1, and at 2 plus 1 3 you would add a -1. Okay, and this 2 to 3 is again 1 to 2. So at 1 you add a +1, at 3 you add a -1. So overall what you get in your difference array is 1 2 0 -2 0 -1. Okay, and you take the prefix sum of this difference array to get your coefficients, basically the actual coefficients. So when you take the prefix sum, this would be 1, and then 1 plus 2 would become 3, 3 plus 0 would be 3, 3 minus 2 would be 1, 1 plus 0 would be 1, minus 1 would be 0. So this actually is basically the coefficients of every element, how many times that is getting added in your queries. So A0, the 0th index is getting added one time, A1 is getting added three times, A2 is getting added three times, one time, like this. Okay. Now, once you know this, next step, what do you have to do is just sort these coefficients and sort this initial array. Okay. So the greatest value is 5, that would be placed with a coefficient of 3. So 3 into 5 would get added to your final answer. So this is your sorted difference array, and when you sort your initial array, you get 5 4 3 2 1. Okay, so this is sorted initial array, and the sorted difference array, this would also get sorted. So when you sort this, it would be 3 3 1 1 1 and 0. This extra 0 is coming, which can be ignored. We would only iterate till n. Okay, so my final answer would be 5 into 3 plus 4 into 3 plus 3 into 1 plus 2 into 1 plus 1 into 1. Okay, this is going to be 15, 12, 27 and 330 and 2 32 and 133. Okay, I hope it is correct. So we get 33. Okay, so I hope the dry run is also clear to you and you would have got the logic what we are doing. So let's look at the code. Okay, so I have defined my int as long, so all the int present in my code is actually long, because my sum can obviously exceed the int range. I need to use long here. Okay, so I take the input first, nq and the array a. So this is like the input part. Okay, and once the input part is done, then I'll initialize my difference array till n plus 1 with all initial zeros. Okay, so I'll initialize my difference array with all initial zeros, and then I'll move to all the queries and accordingly update my difference array. So if I have a query from L to R, I do L minus minus R minus minus to convert it into zero based indexing, and in zero based indexing I would add difference of L plus plus and R plus 1 minus plus. Okay, add a plus 1 to the Lth index and minus 1 to R plus 1 index. In this way, we would add a plus 1 from L to R range when we take the prefix sum of this difference. Okay, so after this, all the queries are done, we'll take the prefix sum of the difference array by doing difference I plus equal to difference I minus 1. So once this prefix sum is done, we have got the actual coefficients in our difference array. We'll sort this in the reverse order. We'll sort the initial array A in the reverse order, and then my final answer is just the product of the sum of the products of corresponding elements. Basically, answer plus equal to AI into difference. Okay. Once this is done, we get our final answer. Okay. So I hope the code is clear. If you analyze the time complexity, this input part you can say is taking order of n time to get the input. Then for each query, these are all order of one operations. So this is taking order of q time to update the difference array, and this prefix sum would take order of n time. This sorting would take, this difference array would be of size n, so n log n. This sorting would again take n log n time, and this for loop would take order of n. Okay, so overall we can say our time complexity is the maximum among them is n q n log n. Okay, so overall time complexity n log n is the maximum and plus q. Okay, space complexity we can say is we are using an array A of size n and this difference array of size n, nothing else. So order of n is our space complexity. Okay, so I hope this problem is clear to you. It was a really nice implementation of the difference array technique along with the prefix sum technique. Okay, so thank you so much for tuning in.